Hey everyone, welcome to this video. In here, we're gonna officially step into T-World and starting Unit 7. The first lesson in this video we're gonna cover is inference for population means when data is unknown. And we're gonna do a one sample t-test for population mean. This is the question that I pull out from the book Problem. And if you guys have that book in your hand, you can feel free to open that up and do it for yourself, but I just copy and paste the original question right here, so no difference. The mu right here is the mean amount of radon detected by all of our radon detectors when exposed to 105 pc per liters of radon. This is kind of like already provided by the question. And what is that question really saying is many homeowners buy detectors to check for the invisible gas radon in their homes. We want to determine the accuracy of those detectors. To answer this question, university researchers placed 12 radon detectors in a chamber that exposed them to 105, not really sure how to say this, but per liter of radon. This is just a unit, not really matter that much. And it given to us the detector readings for those values. And if you count them up, it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12. Which means our n, the sample size in this case, is going to be 12. Oh, it's actually already provided in the question, so yeah, if you pay close attention to this, you should notice, not as me. So we want to determine if there is convincing evidence at the 10% significance level that the mean reading of all detectors of this type differs from the true value 105. So, just as the z-test we've been doing, we also have to include 4 steps. The first step is going to state the mu in this question and stating the null hypothesis and alternative hypothesis. The second step is going to name the procedure and check the conditions, and it's going to be a little bit different, which we're going to include a box plot later. You'll see what I mean by that, and we're actually going to draw it by hand. The third step is doing the part. We're going to actually drawing the normal curve, include all of the values. For those values, starting from now on, you don't have to calculate the values by your hand. You can just type it all into your calculator and do it on your calculator and just copy and paste them down into your paper. But the reason that I was showing you the process of calculating them by hand is you need to have that skill for your FRQs on AP exam or anything else. It's just going to be an essential knowledge skill that, yeah, it's going to be really good for you to be mastered. Okay, so no more talk. Moving to the real stuff. We're first, oh, and I forgot to say the last step is conclude. Write the conclusion, just as we did always. Okay, so finally moving on to the real doing things. The first part is stating the mu. What is mu in this case? Well, even though the question is kind of already given to us, but it's not a bad thing for us to write in our own words again. Mu is going to be the average reading of this type of detector when exposed to 105 pc per liter of radon. And what is our null and alternative hypothesis? Our HO is going to be mu equal to 105, because in the question, the researchers wants to know that if the readings of the radon differs from the true value 105, which means that our null hypothesis should be mu equal to 105. And because this differs from, it's a hint for us to use a two-step test, which means mu is not equal to 105 is going to be our alternative hypothesis. Okay, and that's all for part 1. You can see that it's not a lot different, right, with what we've been doing so far. So moving on to some interesting part right now. Naming the procedure. This is the t-test for 1 mean that we're doing, and remember to state the alpha level is 0.10. There's another important piece of detail that you have to include in part 2, which is the degrees of freedom. And remember from last video, the formula to calculate degrees of freedom is n-1. And what's our n? N is 12. It's our sample size. So you use 12 minus 1 gives us 11. Checking the conditions. The questions didn't specifically say the simple random sample they're using, but they also didn't say that they're not using a simple random sample. So in this case, we're just going to assume simple random sample of 12 detectors. But for some questions, if the question didn't give you the words they're using simple random samples specifically, it might be a hint for you to keep in mind for later questions when they're asking you what are some potential errors or some bias may be made. But not for this case, since it's just a basic introduction of all 4 steps for the procedure in this video. So it's okay that we just leave it right there like this. Second condition, more than 120 detectors of this type. This is the 10% rule. 10% rule, which is we have to make sure the sample size is less than 10% of the total population. So the standard deviation or the standard error is going to be s divided by square root of n. You have to include in this condition right here. And you know, before we usually write the standard deviation data is equal to a number right here, like whether it's p difference divided by n or mu difference divided by n, all squared. I mean, like p difference divided by square root of n or something like that. But in this case, we're not using it, and that's another difference for using a t-test instead of a z-test to doing this type of questions. And the third condition is going to be a box plot. We're going to actually create it using our calculator and copy and paste it, or I mean, draw a rough sketch on your own onto your paper. So there's some conditions or some scenarios we're going to think about when we're creating a box plot. So if the sample size is less than 15, which is a small sample size, and the box plot is symmetric with no outliers, this is a condition that the t-model may be, it's actually, in this case, the t-model is good to go. We're using a appropriate t-model right here, because even though the sample size is less than 15, which we considered it to be small, the original graph that, the data that we entered into our calculator and created the box plot is symmetric with no outliers, then there's some evidence that we can conclude using a t-model for this scenario is appropriate. Another scenario will be the sample size is medium, and the sample size is either, it's between 15 and 40, and the box plot we created is moderate skewness, which means it has some skewness, you can tell from your eyes, but it's at the same time not so much different, which means that it's allowed in this case, and with no outliers. In this scenario, we can also create a t-model with no question. Last but not least is when n is greater than 40, which means we have a large sample size. Even though there's skewness and there's outliers, both of them are okay, because the larger the sample size, the better your data, the better the graph you constructed will be best represent for this data we're using. So those are some scenarios when you constructing your box plot will be better to consider before you actually do that. Okay, so I should have my box plot right here, but for some reason it's gone. So sorry you guys right here. I'm actually gonna check if I have like another box plot maybe showing. Okay, so yeah, this right here is showing. So sorry for the last note that it has not been showing, but since I haven't copied for it, it's no big deal. So this is the box plot we essentially created. And what you should do is actually typing all of this data into your calculator and just create the box plot on your calculator and draw a rough sketch. But do not forget to label the title of the x-axis, which is radon readings. And then we're gonna actually do some explanation for this box plot we just constructed. From the box plot, the data are skewed right, but no outliers. This is moderate skewness, right? And we're using a 12 sample size, which is considered small. So using a t-model in this scenario may be questionable, which means even though at the end we are able to draw a conclusion by using this t-model, we have to think back to ask ourselves, well, what are some potential errors or potential bias that might lead to, or what should we miss something? Just always be questionable to yourself when you're doing statistics. Okay, moving on to part 3. X bar, standard deviation, t, and p-value are the things you're going to include in this part. Also your normal curve, just as always. What's our middle value right here? This is our mu, right? And this is actually the same value we just did in part 1, the mu equal to 105. And the x bar is the value that we're going to put in this curve. And also because we're doing a two-tailed t-test, we have to have another x bar in here that is the same distance to the center mu. And we're going to shade the region of these two tails. Remember to write down the standard error using the formula we just did right here. This is our delta sub x bar for this graph. And this is the p-value in here. This is the t-value, which is just basically using the formula. It will be provided into your brochure, I believe. If you're taking a college class, then maybe your professor will give you some formula sheets, I hope. But that's basically what you need to calculate t-score. And those are all we have for part 3, which compared to last units, especially when doing the two-sample z test for, two proportions for z test, is a lot more clear and very neat, and I love it. So last but not least, part 4, we're going to conclude. At alpha equal to 0.1 level, p is equal to 0.7554, which is greater than alpha. We fail to reject null hypothesis, meaning the average reading of the detectors is 105, but the t-model is questionable because sample was too small. So remember in part 2, we say the t-model is questionable because the data are skewed right and the sample size is only 12 and it's small. That will lead us to some words when we conclude our answer for this at part 4. So you can also say that we fail to reject null hypothesis, meaning we don't have enough evidence to say the average reading of the detectors is different from 105. That's just different ways you prefer to say, but all means the same and all equal when it comes to grading. And that's it for our first question to doing with t-test. This is a one-sample t-test for population mean. And it's not that bad, right? It's kind of fun. And a lot of the ways and the details is similar with the last units. So you can say that how important we should build every fundamental rocks step by step. So you really have a solid foundation. So when we want to build more upon that, you won't feel overwhelmed. And I feel this that way. So thank you so much for watching, and I hope you learned something from this video. If you do, please like and subscribe, or maybe share this video to your friends or teachers. And thank you so much again.